All right, so to do number 27 and 9.3, first they give me this triangle, which is basically a big triangle ABC where they split angle C into two parts and dropped a perpendicular, right? And then they're telling me, okay, so we can find the angle, the area of the triangle ABC by adding the areas of the two right triangles formed, like duh, right? Like the area of the whole triangle is equal to the area of the left piece plus the area of the right piece. You guys all buy into that? That seems like how areas work, right? No. All right, so then, okay, so I'm supposed to find values for sine of theta, cosine of theta, sine of phi, and cosine of phi in terms of A, B, C1, C2, and H. That shouldn't be super hard. So sine of theta should be sine of theta
over hypotenuse, so C1
opposite over hypotenuse, so C1 over B.
Yep.
Sine of phi should be
C2 over A.
C2 over A. Sine, oops, not sine, cosine of theta should be
H over B.
H over B. And cosine of phi should be
H over A.
H over A. Okay, next thing's next. I should be trying to show that the area of the triangle CAD is a half AB sine cosine. Basically, figure out the area of ACD, right? So I'm going to call this the right-hand triangle. Let's call that the left-hand triangle. So the left-hand triangle's area, right, is, let's see, for triangles usually you do a half the
Base times height.
1/2 base times height, right? Okay, so you go, all right, so that's a half, and then the base is
C1.
C1, and then the height is
H.
H. Oh, but C1 is the top of sine of theta, right? So I could rewrite that as a half times B sine theta. You guys all with that? That's really just me rearranging this equation to solve for C1.
Wait, where'd the H go?
I haven't got it yet.
Oh.
And then H is the top of the cosine of theta, right? So I could do B cosine of theta. So I got a half. Oh, they didn't want me to do that one. H is also the top of this other one. You guys see that? It's also the top of this guy.
Yeah.
That's the one they wanted me to use. So that should be A cosine of phi. Both things are actually true. They just wanted me to use a certain one. So I got a half AB sine theta cosine of phi. Is all good with that? And then they want me to do the same thing with the right-hand triangle. And I'll just trust that you guys can execute that. And we would end up with the same thing with the sine and the cosine switch. So instead of doing sine of theta, we'll do cosine of theta, and we'll do sine of phi instead. So do you guys believe a similar calculation would yield that?
Yeah.
Okay. So that's part B. Then part C, use the sum formula to explain why the area of the whole triangle is a half AB sine C. Okay, so if you look at the area of the whole triangle, right, we said that should be the area of the left triangle plus the area of the right triangle. So both of those have a half AB in them. So I'm going to factor a half AB out, and then there's the first one is sine theta cosine of phi, and the second one is cosine of theta sine of phi. You see that? And then that thing there
This is some identity for sine.
is the sum identity for sine. And what if theta and phi add up to in that triangle?
60 degrees. No.
Nice try, dude. They add up to the angle at point C, right? So those guys there, there should be sine of theta plus phi, right? Just by the sum of angles identity. And then you might notice that's 1/2 AB, right? For my half AB upside. And then sine of the angle C. Where that angle C is this whole. So that's angle C. Guys cool with that? Yeah? Good? Okay, cool. What else did they? Oh, that was it. Oh. Thought that was going to be more fun. How do you prove this thing about a half the base times the height? Like, how do you know that's true? Because you've always been told, so you go with it. So why is that true in general rectangles? Or in general triangles?
Because it's half.
Because of general rectangles. Right? Because you take your triangle, you draw the rectangle around it, right? And then that's the same as the left-hand triangle, and those two guys are also the same.
Yep.
But only half of them are interesting to you because only half of them are in the triangle.
Yep.
You see that? So that's where that one base height thing comes from. It's not magic.
Draw a circle of that.
Don't.